Here's your video about solving absolute value equations. First, a quick review of what absolute value means. So absolute value of some number, in this case x, we see these vertical bars or the pipes on either side of x. And what does it mean when we do absolute value? Well, if we have a number inside the absolute value bars, we know that it makes that number positive. That absolute value of -3 equals +3. And if we start with a positive number in the absolute value, that stays positive. The reason we do this is because we think of absolute value as the distance from 0 on a number line. So if we look at a number line and we pick out the number -3, the reason we say the absolute value of -3 is 3 is because it is 3 units away from 0 on the number line. And we use absolute value when we don't care which direction we're headed on the number line. So either way, to the positive side or to the negative side, either direction we would use a positive number for that distance. That's when we use absolute value. And just to get some closure here, absolute value of +3, so there's +3 on the number line, and that point is also 3 units away from 0. So there's the background info about absolute value. Here's a basic absolute value equation. Absolute value of x equals 5. And just like other equations, when we solve them, we're interested in what number could go in place of the x that would make this equation true. And hopefully we're seeing that if a +5 or a -5 is in the absolute value, it would equal 5. So the solutions to this absolute value equation are x equals 5 or x equals -5. And we will see pretty standard these absolute value equations give us two solutions. What about this equation, absolute value of x equals -5? Well, we want to recognize that absolute value always leads us to a positive answer. So for this equation, what value in place of x would make the absolute value negative? There is no solution to that equation. So we'll be on the lookout for only solving equations that ask for an absolute value equal to a positive number. In general, we could say, here's a form of an absolute value equation. Absolute value of x equals some number c. And the way that we can solve this equation is to understand that this means either x equals +c or x equals -c. So moving forward, we will handle these equations by pulling out what is in the absolute value and saying that it could equal either the positive right side or the negative right side of the equation, or whichever side is not the absolute value. Just to give you another idea of when we might try to use absolute value, here's an example that illustrates an idea. Let's say that you are playing a raffle where you will buy a ticket for a number between 1 and 100, and then there will be a drawing. So let's say that your number will equal y, and the winning number that is drawn is going to be w. And usually the way the raffle works is if your number matches the winning number, that's how you win the raffle. So with our variables, you would win if y equals w, if your number equals the winning number. But let's say this raffle is a little bit more generous, where you can win if your number matches the winning number, or if your number is on either side of that number, if it's one bigger or one less. So if you picked 26, then you would win if the winning number was 26 or 27 or 25, if the winning number was one bigger than or one less than your number. So could I come up with an equation to show algebraically what that means? I could say that you could win if your number is the winning number +1 or the winning number -1. That way you would win if the number was 26, or if your number was 26 + 1, 27, or 26 - 1, 25. But is there a way that we could put these two equations together into one equation to represent this idea? Well, you might see something like a plus or minus 1, and that illustrates this idea that y could equal w plus 1 or w minus 1, but it's not easy to work with equations that use this plus minus symbol, so we want to have another way to illustrate this point. Let's go to a number line to build up an idea of how we would use absolute value in this case. So we'll put our winning number on the number line, and we know that you can win if your number matches the winning number exactly, if they are on the same spot on the number line. But you can also win if your number is one bigger than the winning number. Now, what is the distance between these 2 points? And the way we would figure distance on a number line is with subtraction. So setting up a subtraction, I could say y minus w equals 1. So here's a case where you win, and it is when the distance from y to w, y minus w equals 1. Now what about if you picked the number that was 1 less than the winning number? Then the distance, or the difference, y minus w would equal negative 1. So here's how we can show these 2 equations that we saw over here, but now remember how we were using absolute value just a minute ago. If some expression equaled a positive or a negative, we could say the absolute value, y minus w, equals 1. So here's absolute value showing that a y minus w could equal a positive 1 or a negative 1. But let's keep going with this idea just to show how everything is connected. Going back to this y equals w plus or minus 1, we know this is an abbreviation for 2 separate equations, y equals w plus 1 or y equals w minus 1. And now on both of these equations, we're going to move the w from the right side over to the left side by subtracting w from both sides of the equation. That leads us to y minus w equals 1 and y minus w equals negative 1. Exactly those 2 equations that we set up to show those 2 other points on the number line, the one bigger than w and the one less than w. And lastly, to tie everything together, remember what we said about absolute value equations. That we would say what is in the absolute value either equals a positive right side or a negative right side. So here's our model equation, absolute value of this expression equals c, and we would split this up into 2 equations, one that uses a positive 1 and one that uses a negative 1. So here's how we can use absolute value in a situation like this, and we use the absolute value to say our distance could be positive or negative. In this case, our distance was how far away were the numbers y and w, and we wanted them to only have a distance apart of each other of 1. It could be positive 1, a larger y. It could be a negative 1 distance, meaning that y is a smaller number. But to say that the distance is a positive or negative 1, we could say the absolute value equals 1. Let's look at this equation for the next example. Absolute value of 2x plus 1 equals 9. Well, just remember the way we were breaking up these equations before, that the absolute value means that it could actually equal a positive 9 or a negative 9. Our approach to solving these equations will be that we set up one equation that is exactly what we see, we just lose the absolute value bars. The other equation, we lose those bars, but our right side, the side that is not in the absolute value, has to equal a negative. So our absolute value, we think of it as a distance from 0, could be a positive 9 or a negative 9. To complete this problem, we would solve 2 equations. And we're back to our old steps of solving linear equations, so I'm moving over the 1. Actually, I'm going to do that same move to both sides of the equation, but careful here, it should lead us to different results where we had 1 positive but 1 negative. So we're solving for x, next divide both sides by 2. That leads us to x equals 4 on one side and x equals negative 5 on the other side. And we would say the way these 2 solutions work together is that either one or the other is a solution. So either x equals 4 or x equals negative 5. Now let's talk about how does the idea of distance from 0 fit into this problem. Well, in the absolute value expression, it's 2x plus 1. So on a number line, where would that first number x be? Let's assume it's a positive. So that means from 0, we've just moved to the right x units. Where's 2x? Well, definitely that's further to the right. If we move another x units, it will take us over to 2x. but we do need to get over to 2x plus 1, so one more move, we go one more unit to the right, and the picture is not really drawn to scale, but we know that after we do 2x plus 1 more, now our distance from 0 is 9. So our solution x equals 4 would work for the positive side. Move out 4, and then another 4 to get us to 8, and then one more will put us at 9. So our solution x equals 4 is the number we would move in the positive direction, so that 2x plus 1 will equal exactly positive 9. Our other solution, negative 5, how will this one fit in? Well, let's think about our first move being to the left. So x units to the left will put us at negative x, and then another x units to the left will be at negative 2x, and then when we do plus 1, since it's a plus 1, that's always to the right on the number line. So a negative, and then another negative, and then add 1, go back 1 unit to the right, and now we're landed on negative 9. So what number was it that we could make 2 jumps, and then the plus 1 brings us back to negative 9? That's our other solution, x equals negative 5. So we would jump negative 5, then negative 10, and our plus 1 moves us back to the right, so we land on negative 9. We won't look at the graphs every single time, but just a way for us to still understand that there is a strong connection between absolute value and distance, or distance from 0. Here's our next example. You can pause the video and try this one, and then restart, and we'll look at the answer together. We want to continue with the approach we've been using, which is to create one equation that looks identical to this one. We drop the absolute value bars, and the other equation uses not a positive 5, but a negative 5. And now we have our 2 equations to solve. Looks like both of these equations require us to move our positive 2 over to the right side. I'll do negative 2 both sides, here and here. Then our last move, I have a negative 2/3 x, so I'll remove this coefficient negative 2/3 by multiplying by the reciprocal, negative 3 over 2. And that takes us to x equals a negative 9 over 2. It's the same operation over here, cancel a negative 2/3 coefficient by multiplying by the reciprocal, negative 3 over 2, leads us to x equals positive 21 over 2. There are our 2 solutions to this absolute value equation. Let's talk about these 2 examples. Absolute value of x plus 7 equals 0. So there's some number that we can move to the right 7 units, and then our distance from 0 will be exactly 0. And think about, if we use our approach where we set up 2 equations, we would think about one equation has a positive 0 and the other equation uses a negative 0, but there really is no difference with a positive or negative 0. So an absolute value equation equals to 0 is only going to have one solution. I'll drop the absolute value bars, solve it, we get x equals negative 7. It is the single solution to an absolute value equation that equals 0. And do you remember what we said about absolute value equations equal to a negative number? Automatically no solution. Absolute value will always give us a positive result. Now the next example, we have an absolute value equal to an algebraic expression, not just a number, but our approach is the same, that this will become 2 equations without the absolute value, and that the opposite side from the absolute value, we say one equation uses the positive or uses it as is, and the other equation will use a negative. So our first equation, 3x plus 5 with no absolute value, equals x minus 2, exactly what we see. The other equation, 3x plus 5 equals negative. And it's important that when we have 2 or more terms, we're careful about how this negative is used. It will need to be applied to each term that we have. So I'm putting it in parentheses, and I'll make that next adjustment right away. Let's begin to solve over here. So I need to collect terms, x terms on the left and numbers on the right is what I'll do. So some swapping in both sides moves gets me to 2x equals negative 7, and then I'll divide by 2, x equals negative 7 over 2. This equation, first I'll distribute this minus or flip signs of each of these terms. Somehow I should get to a negative x plus 2 on the right side. And now I'll do my both sides moves and get to a 4x equals negative 3. And to finish solving for x, I'm dividing both sides by 4. X equals negative 3/4. Here's our last equation, just to talk about how we would handle it when we have absolute value on both sides of the equation. Well, remember that absolute value, our solutions are what's inside could be positive or negative. So when we have an equation where an absolute value is on both sides, this is a way to say that the two sides of the equation are either exactly the same or they are opposites. And that's pretty much what we've been doing all along, so we're handling this in the same way as the others. I'll bring down one equation, losing the absolute value bars. 7x plus 3 equals negative 4x plus 1. And the other equation will be 7x plus 3 with a negative right side. If I had a negative 4x plus 1. So you should see that the way we handle this equation is no different from the way we handled the previous equation, where we had an absolute value on just one side of the equation. Let's solve these, doing the both sides moves to get x's on the left and numbers on the right. 11x equals negative 2, and then divide by 11, x equals negative 2/11. Our other equation, I'm flipping signs to a positive 4x minus 1, and then collecting x terms on the left with the number on the right, and then divide both sides by 3, x equals negative 4/3.